Okay, welcome to week 6. This week you are taking your midterm, but in addition to that, we're doing a little unit on data visualization, and specifically the data we're going to be using is actually sound. So data visualization is a big topic. I'll post a bunch of examples, but it can range from anything that's pretty maybe conventional, like charts and graphs. Think of your stock market graphs. It's a very kind of conventional method of data visualization, taking some numbers and charting them like a line. There's a lot more creative versions where you're taking big data sets and visualizing different components of them. But the crucial thing about data visualization is that you're doing this process of mapping. So you're taking some information and associating it with some attribute of what you're seeing. So for example, you could imagine a data visualization in which someone has a thermometer and associates the temperature with color. And so maybe over the course of the day, you see this color change slowly as it gets warmer and then changes again as it gets colder. It's a very basic version, but that mapping exists between temperature and color. You can imagine getting very, very complicated. If you had a data set that had a whole bunch of different features and parameters, you could have a whole bunch of different mappings and make something very complex. So due to some of the constraints of the time we have in this course, we can't fully dive into all the kind of rich possibilities of data visualization, but there are a lot of them. Instead, what I want to do is to do one particular type of visualization, which is with sound. So this is a very fun exercise to do because it's already something we see a bunch in our daily lives. Like if you think about every time you go to a concert, there's usually some kind of visual component, whether that's a light show, whether that's a projection behind the artist that's, showing really cool kind of crazy visuals. A lot of times those are synced up in some way to the music. Sometimes they're not, but a lot of times you at least have some synchronization between like the beat or the pulse or the rhythm of the music and kind of the tempo of the visuals as well. They're able to sync that up. And so you can get even more in depth. You can start creating more mappings, like maybe certain pitches or certain notes of the music cause different types of effects or different types of colors. You can really go as deep as you want. But what we're going to do in this lecture today is check out a library that processing has available called Minim, which is a sound library. We're going to see how to import a new library, and then we're going to see how we can use that to act as like a beat detector for a song, so that we can have aspects of our visuals in processing mapped to the beats or the pulses of a song. And so we can start to build a musical visualizer, basically. So we're going to take a look at importing a library and then beat detection. In the next lecture, we're going to look at a slightly more complicated sound visualization strategy using something called an FFT, and we'll talk about that next lecture. But let's go ahead and build our beat detector today, and we'll see kind of where we could be heading with this type of visualization. All right, let's jump into it. Okay, so here we go. Week 6, Class 2A. You might be wondering where Class 1 is. Well, I'm treating your midterm as the Class 1, so the two lectures that we're covering today will be Class 2A and 2B. Now, one thing before we really get going here with the libraries is that just like when we worked with image files or any other kind of external file, we need to have a data folder inside of our sketch folder that has the song we're going to be using. And I will have that up on the GitHub repo for you to use. You're also welcome to use your own. Just disclaimer that it takes some tweaking to kind of get some of the sensitivity settings to match your song. So if yours doesn't work right away when you use your own track instead of mine, just note that you might have to tweak this sensitivity parameter, which we'll see how to do in a minute. But just know that there might be a little bit of changing of some numbers to get yours to work really well. So make sure you have a data folder with our song file in that. Okay, great. So what we need to do is load a library. All right, let's talk about libraries for a second. So processing has a whole bunch of libraries, and what these are basically code that exists outside of processing that you're able to import into your processing sketch and use it just like you would if you're writing any other processing code. And they have a whole range of topics you can see up here. If we look down here, there's, we're going to be using PZCam later. That's for making a really easy mouse-driven camera when we're doing 3D, which we'll be doing after this unit, actually. There's a whole bunch of things with data. This might be a good place to come look to see what libraries exist for your final project, because maybe you want to get into some of these. There's augmented reality libraries. There's a whole bunch of stuff. But what we're concerned with today is something called Minim, which is a sound library. Here we go. So I'm going to click on that. So we're going to come back to this, but this is Minim's kind of homepage, and we might use it as a reference later, just like we use the processing reference to help with our code. So let's just keep this here for a moment, but come back to our sketch. So if we need to get a new library, we can come to Sketch, and then we go down here to Import Library, and then Add Library. Now I already have it. You can see here Minim is down here, but you probably don't yet. So we're going to go up to Add Library. It's over here. Okay. It's going to pop up with kind of our contribution manager. So this is where all of our libraries are accessible. And I'm just going to search for Minim. Okay. And we can see that here it is, an audio library that provides easy to use classes for blah, blah, blah. Okay. And these are the authors. Good to note and give them some applause. I already have it installed, you can see here, but for you, you would click on it once, and then there'd be this install button down here. And you click that. And that's all you need to do. In some cases, you may need to restart processing if it's not working at first. So just note that if you're getting anything weird, try quitting processing and relaunching it again. Okay. Now, how do we actually use a library once we have it downloaded? Well, we come to Sketch again, we go to Import Library, and we find the library that we want to be working with, Minim. There we go. And that automatically imports all the stuff, basically, that we're going to need, all the code behind the scenes that we're going to need to run our sketch with the Minim library. Now, one other note before we jump in is that if you go to your file, examples for processing, most libraries, popped up over here, most libraries come with some examples for you to work off of. So processing already has some by default. Some of this should look familiar. Arrays, image, a lot of stuff that we've seen before. But if we come down here, contributed libraries, we can see all my libraries I currently have installed, and here's Minim. So here are some example processing sketches that sort of highlight different features of this library. And the one we're doing today, I should say, is kind of based off of one of these examples with the beat detection. Okay, so that's just good to know that you can find examples for each library. Okay, so first things first, we need to use the Minim library to basically import a song into our sketch and set up some initial parameters about the thing that we're trying to do. Okay, so let's get that rolling. So I'm going to do a setup loop and a draw loop today. Alrighty. Now, up here, kind of next to our imports, maybe I'll just make a comment here, imports from Minim Library. We also need to do a few things to initialize the library. So if you remember from our work with classes recently, or any other variable, we need to declare that at the top here first. So to initialize the Minim library, just to basically like get it rolling basically, we're gonna say minim and then minim. So basically we're gonna use class minim and we're gonna name it minim. Just like when we had like a class particle and then we gave it a name, or a p image and then we named it something. That's what we're doing with this. We're just gonna have an instance of the library minim here, and we're gonna name it minim. So this is what we'll reference later on. Okay, so let's do that. So initialize library. Now we need to do a couple other things. So because we're gonna be importing an audio file and playing it and doing some stuff with it, analyzing it, we need to set up something to actually have that audio file come in. And what we can do for that is we can say audio player, and then so again this is the class audio player, and we just need to have a name for it. And I like to kind of keep it clear in these examples, so I'm going to say song. So basically we're going to use the audio player class in Minim to create a song, basically. Okay, cool. Now the last thing we're going to import here is, I mentioned that today's goal is going to be building a beat detector so we can kind of sense the pulse of the song or the rhythm. So beat detector. So Minim has a beat detector function already built into the library. That's kind of the whole reason why we use libraries, is they have a lot of this stuff built for us already. So what we can do is we can make one instance of the beat detect object, and let's call it beat. So imported Minim, we're using the audio player from Minim, and we're also using the beat detector from Minim. Cool. All right, so these are the three things we need to sort of initialize from the Minim library to do what we want to do today. Okay, so let's get this song up and running and make sure that that's playing okay. I'm just gonna put a size here because why not? And now what we need to do, now that we've before, like, we'll initialize a variable like a p image or a float, and then a lot of times in the setup section, we'll actually assign an initial value to that. We're going to do the same thing for a lot of our Minim features here. So first things, we need to say Minim is going to be a new Minim object. Now this is kind of maybe some new looking syntax here. We only have to do this once, which is nice, but just basically know that all we're saying here is, okay, we've initialized this idea of having our Minim library going, and we just need to say, like, we're gonna set the initial parameters based on some stuff that's happening behind the scenes here. Let's not worry about that part too much, because that will always be the same. So this is basically set up our sound library. Okay, now we need to load the song that we're going to be using today. So we already decided that we have an audio player for our song. So now what we can say is this. We can say, well, let's get a comment in here first. Say we want to load our song file. So we're going to say song equals minim dot load file. This should look a lot like, image equals load image. Very same idea, but now we're just doing it with an audio file instead of an image file. Load file. And the name of this track is denmark.mp3. And this has something to do with the audio buffer. Let's not worry too much about that right now. That's a deep subject that If you're curious about more, we can talk about, and there's also documentation on the Minim Library. But just know that you'll probably be okay with keeping this number this way for your project. Okay, so now we've loaded our track into the variable song. Great. Now I'm going to do one other thing. Let's say I'm going to be working with this sketch for a while, or maybe I want it running for a while. I want our song to loop, so I'm just going to say song.loop. So I'm going to load song file and loop it. So that way when we get to the end of our song, it just starts at the beginning again. Okay, great. So we have our library set up. We have our song file loaded and looping. Let's see if we hear anything yet. Cool, there we go. So this is the track we're working with. I did not make it. I will put credits to the artist in the description of this video. But I picked it because it maybe would be hard to hear on this video, but when you download this track, it has a pretty steady and clear beat to it. So I wanted to use this as a really good example for how to detect, how to use the beat detector in a very kind of clear way. And then later you can kind of get more crazy and use some more adventurous music in the background. Okay, so our song was loaded and it was looping. Well, we didn't get to the end of it, but it would have looped. Okay, very cool. So now let's get to the whole reason why we're doing this, which is the idea of the beat detection. So just like we had to set up this song and we had to set up our sound library, we also need to set up our beat detector. So set up beat detector. And how we do that? Well, we decided that the beat detector was going to be named beat. So let's use that. So beat is going to equal a new beat detector function. Cool. And then the other feature, and this is what I was talking about earlier with the sensitivity. So we can set how sensitive this beat detector is with just one number. So we can say set sensitivity. I found just from messing around with it that 250 worked really well for this song. We'd have to check the reference. I believe this is on a range from like 0 to 500 or 1,000. I can't quite remember, but I think by default they're often around 300, I want to say. But I found that 250 is right about the right sensitivity for this song to basically detect the beat. Now, if yours, now what would it mean if it wasn't the right sensitivity? So maybe because I kind of want to just hear when these like kick drums are happening, like the main pulse of the song, if it was more sensitive, it might be picking up other parts of the song as the beat. So it would have like, it would be basically detecting too many beats. If it wasn't sensitive enough, maybe it wouldn't even detect the bass drum at all, and maybe we wouldn't get any beats. So it's a little bit of a Goldilocks situation to find what works for your song. So just know that. So set up beat detector and set sensitivity. Very cool. Okay. So now let's get down to actually using this stuff here. So down here in the draw loop, because we're going to want to be continuously trying to detect the beat, not just once at the beginning. So that's why we're going to use the draw loop here. Well, first things first, I might as well just put a background, because why not? You know what? I'm going to go with white background today. Whitish. Okay. Now, first thing we need to do is tell our processing sketch to start running this beat detect function. So basically say, while our song is playing, keep looking at the song and try to detect a beat. So the way we do that is we say beat detect. And then what audio do we want to be looking at to detect the beat? We want to use our song. So I'm going to say song.mix. So this is basically saying, look at all the sounds in our song.mix, and try to detect a beat. How about listen? I guess that's a better metaphor. Listen to the song and detect beats. Okay. Now, let's see if this is working. So I'm going to set up an if statement here that says if beat is on set. Okay, what in the world does that mean? Let me finish our if loop here, or if statement. So basically what this is saying is, okay, so the beat detector is continuously running every single frame of our draw loop. It keeps looking to see if there's been a beat detected. And this is our way of saying if there has been a beat detected. So onset, that's sort of like, something has happened, that's basically saying like the start of a beat has been detected. That is going to result in a true statement with our if statement conditional here. If a beat has not been detected, then whatever is in here won't be run. So basically using our classic if statement to say, has a beat been detected? If so, do whatever's in here. If not, don't do whatever's in there. So we'll say conditional to check if there is a beat detected. Okay. So let's see if we can do a very kind of simple visualization to see if this is working. So maybe what I'll do is I'll say background 0. So in theory, we're drawing our background to white, but if a beat is detected, maybe we want to make it black really quick, just to confirm that this beat detection is actually working. So let's try that out. Okay, so no beat yet, which I know is actually kind of nice. There we go. You can kind of see it flashing black with each of the bass drum kicks. Good, okay, so that's actually working pretty well. Which is no surprise because I spent a little bit of time making sure that number was right. But there we go. So let's quick recap. We set up our beat detector to look at our song, to listen to our song. And if we found a beat, if a beat has happened, then we changed our background very briefly to black. Very cool. Now let's just do one more slightly more interesting thing with this. And this is kind of taken from the example on the beat detect reference page. So actually if we came over here, the type of thing we're doing is analysis. We're analyzing the song for a beat. And then actually the first thing here is beat detect. And so we're using is onset. It's good to know that is hat, which is the hi-hat for like a drum, is kick, the kick drum. So there's some other options, snare. So there's a couple other things you could do inside of beat detect. But just know that is onset is what we're looking at. And I've kind of used a version of their example for our example today. So what I want to do is basically, instead of just changing the color every time there's a beat, I want to draw a rectangle, like a kind of a bigger one at first, and then have it start to fade away. And the reason I'm doing this is I just want to make a bit more of like an interesting looking visualization, something a bit more like what you might see if you were, at a concert or making some kind of video component, like a YouTube video of a song, something like that. So what we're going to do is draw a rectangle, an ellipse, and have the radius of that ellipse get smaller and smaller and smaller after we've drawn the beat. So let's take a look at how we could do that. So first things first, I'm going to, outside of my beat detection here, I'm going to draw our ellipse. first. So I'm going to say ellipse. Let's just put it in the middle. Divided by 2, height divided by 2. And now we're going to use a variable for the radius. So we're going to say it's r wide by r tall. We're going to need the r for radius variable. So why don't we use that, set that up here. I'll say radius of the ellipse. Let's do the float r. Let's say initially we want our radius to be 80 pixels. Okay. So there we go. All right, so let's run this just to make sure we see our ellipse. There it is, very cool. I feel like we need like maybe a different color here. Why don't we give it, how about fill 255, 182, 147. I didn't just come up with those numbers. I also, just for fun, you know what, I'm going to do Hsb mode. Color mode, Hsb. So now we are hue, saturation, brightness. So color for ellipse in Hsb. And you know what, I also want to do no stroke. There we go, cool. Alrighty, so now how are we going to associate the ellipse with the beat, and how are we going to make it change size? Okay, so here's my little scheme that I borrowed from the example, which is a pretty clever idea. So what I'm going to do is basically say, so right now our radius is 80, right? Every single time the draw loop happens, over and over and over again, our radius of our ellipse is 80. So basically what I want to have happen is every single time the draw loop goes, we're going to decrease that radius through a particularly helpful and efficient method. So what I'm going to do is I'm going to say r times equals 0.95. Okay, you might be like, what are we doing here? So let's think about this. So initially our radius is 80, and I say times equals, so that's the same as saying r equals r times 0.95. So basically just multiplying the radius by 0.95. Now what does 0.95 give us? That gives us 95% is one way to think of it, of the original radius. So it keeps getting smaller and smaller and smaller. Let's just, to illustrate that, 80 times 0.95, we get 76. Okay, so now the second time the draw loop goes, our radius is now decreased to 76. All right, so 76 times 0.95, oops, now we're down to 72.2. And so on and so forth. So basically this is a way to slowly decrease our radius every single time the draw loop happens. So let's just see how that's working before we even use our beat detect yet. Okay, cool. So you saw it sync, right? Or sync, fade. I mean, I guess it's kind of like syncing. There it goes, cool. So that's kind of a nice effect, right? That slow decrease of radius gives it this nice kind of fade out or floating away kind of effect. Now, why are we doing this and how are we associating it with the beat? So here's the plan. Every time the beat is detected, we're going to reset that radius back to 80. So that should give us the effect of drawing an ellipse and then it fading out, and then drawing another ellipse on the beat and have it synced up with the song. So all we can have to do here is say r is equal to 80 again. Set radius of ellipse back to 80. And I'll say here, slowly decrease, or maybe fade, radius of ellipse. All right, let's see what we got. You see, it's not quite perfect, right? There's a little bit of glitchiness at the beginning. Once the beat comes in strongly, now we really see what's happening. Very cool. So that every time the beat was detected, we redrew the ellipse at the full 80 pixel radius. And then in between beats, the radius would get smaller and smaller and smaller until there was a new one, and it went back to 80. So this is a kind of a quick example of how we can start to associate aspects of the sound, in this case the beat, with elements of our illustration and of our processing sketch. So we associated this ellipse shape with the beat and changed its size with this kind of effect of fading it out. And you can imagine, we had one ellipse, but this could be a whole system. You could use your particle system and have all of those radius be radii associated with the beat or something like that. So the beat detection is a very cool tool for sound visualization. It's kind of like the first step because rhythm's arguably the most kind of visceral component of the sound. So when you go to a live show, it's almost certain that the lights or whatever are going to be synced to the beat of the song. So it's a great place to start with your visualizations. Now we're going to look at one other tool in our little unit here on sound visualization, which I mentioned before, called the FFT. And I'm going to show you an example for the assignment that uses both of these things, both the beat detector and the FFT, to create a visualization of sound. So we'll get into that more in the next lecture. All right, thanks everyone.